So, welcome back. So, let us now see table number 1, which is what we are looking at, saturation line, and the base is temperature. So, table 1, saturation line, base temperature. What you see here is a PT diagram again, and as we know that saturation line starts from TP up to CP, triple point up to critical point, and the triple point is at 0.01 degree centigrade and 0.000617 MPa, megapascal. What do I mean by this base as a temperature? That is what we want to understand. This is my liquid vapor saturation line, and let us look at this point which lies on this LV saturation line. This may be a saturated liquid, saturated vapor, two phase, whatever it could be, but it lies on the liquid vapor saturation line. And as I have already said that table 1 and table 2, they deal with liquid vapor saturation line only. So, table 1 base is temperature. It means that the temperature has been given to me of any system, of any state. I know the temperature, and corresponding to this temperature I can find out of this thermodynamic state what is the pressure. Because this state lies on this line, and because it has got a single degree of freedom, if you remember the Gibbs phase rule, we have to know only one parameter. The moment we know one property, pressure or temperature, we know the other property very well. So, exactly here what has been given to me is temperature of this thermodynamic system, and what I can get from here is corresponding Psat or saturated pressure at given temperature. How do I get that? Here I have been given that this system is at a particular temperature. I just locate that point on this line, I go vertically up, I locate this point of intersection on this LV saturation line, and corresponding to that whatever pressure I get is what we call it saturated pressure at this temperature. Table 1 gives these parameters. So, this is my table 1. I have just taken a snippet of this table 1 from the steam table, and you can see that I have just shown 3 temperatures here. So, I am not going through all those 4 or 5 pages, but I have just taken some temperatures for example here. Obviously, this table starts again from TP to CP. So, triple point which is at 0.01 degree centigrade and critical point which is at 373.9 degree centigrade, and just look at these first 2 columns. Do not look at these properties which is what was shown over there, but just concentrate on these first 2 columns, and the first column what you see is temperature. What do I mean by this base temperature? It means that the first column is temperature. If the base is pressure, the first column will be pressure. So, whatever has been given to me of this system, if I know the temperature, I will always refer to table number 1 and locate the temperature in this column, and corresponding to this the second column which is Psat value gives me the pressure which exists at this temperature, alright. So, this is a saturation pressure at this temperature, and therefore, this is what we call as Psat T, it is given in MPa. So, this is the only difference between table 1 and table 2. Table 1 has temperature as a base, and corresponding to this temperature on the LV line what we get is Psat T value. Let us now go to the steam table and just have a look at table number 1 to see how does it look. This is table 1 saturation line base temperature. So, you can see here saturated water and steam temperature based, and you can see the first column here is temperature, and the first point is 0.01 degree centigrade which is the triple point. It starts from 0.01 and corresponding Psat T is 0.000617 which I had shown in the snippet. As the temperature starts increasing now from 0.01 degree centigrade from TP up to CP. So, you can see now there are incremental values of temperature. This is a 1 degree centigrade increment right now, and corresponding to that what you get is a corresponding Psat value. If I just show you a value at 100 degrees centigrade, let us have a look at that. You can see here at 100 degrees centigrade, the Psat T is 0.10142, 0.1 MPa. I can go down, the temperature increments are still 1 degree centigrade, and you can see here the last value is Tc, which is the critical temperature 373.946, and corresponding to that you have got a critical pressure which is Psat T at this temperature, which is 22.064 MPa, and the increment is still 1 degree centigrade throughout. That means table 1 has a temperature with an increment of 1 degree centigrade throughout, running from Tp to Cp, and what you get now here are all the values of different properties. We will come back to these properties later, little later. Let us just clear our concepts of table 1 and table 2. Let us now go back to the slides again. Let us now come to table 2, saturation line, now base is pressure. Again you have got the same diagram, PT diagram, and you have got a LV saturation line running from Tp up to Cp, alright, and again locate one point on this line which is for which we got the thermodynamic system lies on this point, because table 1 and table 2 deal with these lines only. So here now I say instead of temperature the pressure is a base. So I will go in opposite direction to what I have done earlier. I will locate the pressure. Now I have been given pressure as a given quantity. So I will locate the pressure, go horizontally, see the intersecting point with this system, and corresponding to that I will get now temperature. Alright. So what you see here, table 2, locate the corresponding pressure at a given pressure, just find out this point and get now the Tsat P value here, the saturation temperature at given pressure. Earlier we were getting Psat at T, and here what you get is Tsat P. So coordinate of these points, coordinate of the system over here will be Tsat and Psat. Any system which lies on this line, LV line, it will have temperature and pressure coordinates as Tsat and Psat, or Tsat P and Psat T. That is what we can say about this. Let us now have a look at table 2 in short. So this is table 2, saturation line, base pressure, and the first point is triple point pressure, and the second column what you see here is a Tsat corresponding to this pressure. So Tsat P is what is given in the second column. So the pressure values here will go from triple point pressure up to critical pressure, the triple point pressure being 0.000611 MPa, and corresponding to this P value, the second column gives you Tsat P, alright. So similarly now I will go from triple point pressure up to critical point pressure in this table 2. So here you can see that this is my critical pressure 22.064 MPa, and corresponding to that you got Tsat P, or a temperature which is a critical temperature 373.946, alright. So the corresponding to any pressure and temperature, the properties that you see here in these tables are going to be the same. The only difference being what is given to you, or what is your base, pressure or temperature. If pressure is given to you, I will go to table number 2. If temperature is given to us, I will go to table number 1, and that just decides which table I would see. The property data that I get from both these tables are going to be the same. Let us now go to the slides again. So I am again going to show in short the same thing, the snippet of this table 2 which I have just shown you, again going from triple point pressure to critical point pressure here, and just giving you value of let us say 0.1 MPa, which is close to atmospheric pressure, and corresponding this to this 0.1 MPa you see 99.606, which is close to the boiling point, and we know that this is the boiling point close to atmospheric pressure, alright. Similarly, as I just shown you, at critical pressure what you have is the T sat P, which is the critical temperature over here. So, what have we learned till now? We just saw the steam table, we went through the steam table and saw table 1, table 2 and table 3, just the titles. And what we have seen now is steam table, table 1, we have understood the concept of temperature as a base and pressure as a base. Thank you very much.